Hi Geometry, welcome. We are taking a look at some pretty fun stuff in geometry. Now, I know that for some students this actually is not their favorite, but don't let that make you defeated before you start. This actually isn't a difficult concept, you just have to think. Now, I know a lot of us would prefer to just mindlessly solve, right? If we were truthful, we would say that it is easier, isn't it? But geometry is stretching our mind a little and making us think, why is that true? And I think in the world that we live in, it's important to not just mindlessly accept facts that are given to us on social media or the news, but to say, where did that information come from? How do I know that it's valid, that it's true? And so I think that geometry is making us think a little bit more rationally about those thoughts. And that's why we don't cover this type of math until you're in high school, because that whole reasoning process is not there until you mature and develop. And you young people are certainly mature, and you're rational-minded young people. Can you imagine trying to reason this through with a toddler? Have you all ever seen a toddler in a grocery store when they didn't get their way and they threw a temper tantrum? I'm sure none of you all ever did anything like that, right? But you can't really reason with it. But I want, and their mom in tears might try to explain, we're gonna eat dinner, and then if you do this, then you can. And sometimes the reasoning just isn't there. But I want. And they don't always understand what's good for them or what's needful. Well, as young adults, you understand that this may not always be pleasant, but it's needful and it's good for us, isn't it? To stretch our mind and to think a little bit. What fact can I support this with? Have you ever debated with someone that wasn't basing anything on reality or on facts or on truth? Well, you know that it's very difficult to do. So that's why we're looking in geometry at what we would call proofs. Now, that might bring much fear and trepidation. Maybe you tell your parents, we started proofs today, and they say, oh, I remember those. Don't let it intimidate you. Proofs are simply stating what you know is truth as to why. So if you'll look with me on page 151 in lesson 24, you'll see a box here, and it's giving us a lot of the proofs, a lot of the facts that we're going to base future proofs on. Now, the addition property of equality means if I add the same to both sides, my equation is still equal. Same for subtraction, multiplication, and division. The symmetric property says if A equals B, then B equals A. I'm just switching the two. Reflexive, A equals itself. Right? If I'm looking in a mirror, I see me, not someone else, right? So it's a reflection. We'll use that a lot when we're looking at triangles and different things. You'll say that part of the triangle is also the same in the other triangle, therefore it's reflexive. All right, transitive property. If A equals B and B equals C, then A equals C. That's the transitive property. You'll use that one a lot too, so commit that to memory, the transitive. And the last one is substitution. If A equals B, then B can be substituted in any time for A. And we've used substitution before, haven't we? Now, our book gives us some examples, and then they show us how to solve a regular algebraic problem by writing the algebraic proof beside of it. What we did, we used the first statement is always given. Anytime you start a proof, you write given. And then you'll write which property you use. And you'll notice a lot of them use like distributive property, the multiplication property, the subtraction property. So I'm just looking down through my examples on page 152 and 153 to look through how to solve those algebraic problems by showing my proofs. Why is it true? Now let's take a look at page 154, practice A. All right, so I have x plus 5 equals 4x plus 2. All right, so the first thing I want to do is I want to move my variables to one side. So I'm going to subtract 1x, all right? So I'm going to subtract 1x. Now, the first one will always write given, and you can draw a line there, right? Now, I subtracted 1x, and I did it to both sides, so it's the subtraction property of equality. right? So I subtracted the same to both sides. So that's going to cancel this out and leave me with 5 equals 3x plus 2. All right? So all I did was subtract, and I guess actually I showed the subtraction here, but this should be written here. So I should have just subtracted and shown you. All right, so my next line, what am I going to do? Well, in order to get my variable by itself, again, I'm going to use the subtraction property of equality, because I'm subtracting the same to both sides. So the next line would be 3x equals 3. How did I get there? I just subtracted, right? Now, I've got to solve, so I'm going to use the division property of equality. How do I know? I divide both sides by 3, so x equals 1. All right? So I know, based on the division property and how I solved that I have justified each step. I subtracted again, I subtracted twice, I divided, and then I got my solution. So I simply, and at the end your book wrote simplify, right? Because when you did that final step, I'm just simplifying. All right. Oh, I left out my simplify. All right. So I just simplified each one. So I'm showing each step as I work it. So your book does that there. All right. Now let's take a look at your other lesson practice. So on letter B, it says solve and again provide a justification. So you're going to do the same thing where you're working it out and you're explaining on the opposite side. Now, letter C, the steps of the proof are given below are given in the correct order. However, the justifications for each step are out of order. Determine the correct order of the justifications. So we know the first one is always given, so we know that's correct. Now let's look at between step 1 and step 2, what took place. Well, I can see that they have, so it says the steps of the proof are given correctly, but the justifications are out of order. So I have, it looks to me like they've gotten rid of the fraction. Do you all see that from the first step to the next step? So in order to do that, how did they get rid of the fraction from 2/3 to 2? What did they do? Did you catch it? They multiplied everything by 3. So I know that next would come the multiplication property of equality. Now, after that, they moved 18 to the other side. So in order to move it, you would have to subtract. So that would be the subtraction property. So we figured out the first 3, and then you'll need to keep going to finish that. So do you see, all I'm doing is looking line by line and seeing what step was taken each line to see what was next. All right, so that's all that you're doing on those. The area of a rectangular floor of a shed is 40 yards squared. The length of the shed is x plus 2 yards. The width is x minus 1. Find the dimensions of the shed. Provide a justification for each step. All right. So I am solving those two. So let's take a look. So I know that, let me erase this. So I'm on the last practice of lesson 24, and it's letter D. So it told me that the shed was 40 yards squared, but it told me that the dimensions were x plus 2 and x minus 1, right? All right, now I have to distribute that. So this would be my given. Then I'm going to distribute. I'm going to use the distributive property, right? So that would be x squared minus 1x plus 2x minus 2 equals 40. I'm going to drop the label, but you guys understand what happens. Now I'm going to simplify by combining like terms, right? So I've got 40 equals x squared plus 1x minus 2, right? Now, I'm going to subtract 40, so that's going to be the subtraction property of equality. So if I subtract 40, that's going to leave me with 0 equals x squared plus 1x and then minus 42. Now I'm going to have to factor in order to solve because I have solved this. So 0 equals, and I'm going to be factoring. So here I subtracted, and then again I simplified because I combined those together, right? So I simplified, and now I'm going to actually write factor because this is the process that I'm doing now. So I'm breaking apart my x's, and then this tells me that they are different. So one's positive, one's negative. The larger will go with the positive. So what are the factors of 42? 7 and 6. So x equals negative 7 or x equals 6. Well, I know distance cannot be negative 7. So therefore, I know that x equals 6. So I know that this first dimension, 6 plus 2 would be 8. And then 6 minus 1 is 5. And each of those would be yards, right? And I figured that out based on what was given, and then I factored down. And then it said provide a justification. It said find the dimensions of the shed, and we did that. We knew it couldn't be negative 7. Distance cannot be negative. So that is lesson 24 in our Saxon Geometry. So we're beginning proofs. Now, another important fact that we're going to be covering this week is lesson 25. Now, lesson 25 is all about triangle symmetry, and we're looking at side, side, side. So if I have two triangles and they're similar to each other, and I tell you that their sides, side, 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 are equivalent, then that means that all of the triangles are equivalent. And so I can use when I'm solving my proofs, I can use side, side, side as one of my proof reasoning. So this is our postulate 13. And remember, I told you that you don't need to memorize the numbers, but you need to understand what it's saying. So side, side, side would be how you would write it down. So it says on page 158, if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. And so they show you pictures on page 158 right in the middle. And they have triangle ABC is congruent to triangle DEF. And it's important that in geometry that order is always there. You'll notice that A has 1 etch mark and D has 1 etch mark. B has 2, E has 2. C has 3, F has 3. So you have to say them in the right order. And I know you may say, is that really a big deal? But it is, because if you take a standardized test and you don't look at the pictures, the order that it's written is the same. So that's why it's very important. Now, an important proof that you're going to use later is Cpctc. And you'll see that in other curriculums as well. And that abbreviation stands for corresponding parts of congruent triangles are congruent. Now, when I was in high school, I used a different curriculum than Saxon, but I still remember Cpctc. And so you'll hear other people in other math classes say that similar reasoning. That if you know that side, side, side is true, then you also know all the angles that are corresponding are true. And the reason you'll give for that on your proof statement, you'll first say side, 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 and then the next reason is Cpctc. So if you know that the triangles are congruent, then their corresponding parts are congruent as well. So that's why it's so important. All right? And always look for the order, because that order is important. Now let's look on page 160. And again, we're in lesson 25. It says identify the corresponding angles and sides. So it's wanting you to write what parts are congruent. And you've got to look at your etch marks. So I know that angle Q is congruent, and that's 1 etch mark, to angle U. All right? And then P has 2 and S has 2. So P is congruent to S. And then angle R is congruent to angle T. All right? because of our etch marks. Now it says also identify sides. So I know that Q had 1, so QP, side QP is congruent because Q started at 1 and P is at 2, then find 1 to 2. So that would be US. All right, and order does matter because P came first, U had to come first. P came second, S had to come second. All right, so now let's do the next one. I've got S is to T. S is to T, and that's 2 to 3. So I've got to do 2 to 3, so that would be PR. So P is to R as S is to T, and that's right. All right. And the last one we would do is QR. QR, side QR is congruent. Now Q has 1 etch mark to 3, so I've got to find 1 etch mark to 3, UT. All right, and I live in Tennessee, so the University of Tennessee is very important, and we just had a win this weekend. So QR is congruent to UT. All right. Now, letter B says write a congruent statement for the 2 triangles. And this is extremely important because you need to make sure you follow the right order. So if I say triangle A, B, C. Now A starts out and it goes A, 1 to 3. So A, B, C. So I've got to go D, E, F. And don't just pick that because of the order. I've got to make sure I'm going 1 to 3. So I made sure to follow that pattern. A, B, C, 1 to 3, as 1 is to 3, D, E, and F. All right, so watch your markings and make sure you've set that up right. Letter C, identify the congruent sides and angles of the 2 triangles. So you're going to have 3 angles and 3 sides that you have to mark as congruent. Watch your etch marks on letter C. Now, and write 6 congruent statements. All right, so those are going to be your congruent statements. All right, now if I were to write the triangle statement on letter C, I would say triangle. I'm going to start with KJL. KJL is congruent. Now K was 1, J is 2, and L is 3. So I've got to start with 1, 2, and 3. So it'd be TSU. TSU. Now be careful because you all may say, well, I want to do STU. No, but because see, S has 2 markings. K only had 1, T only has 1. So I have to start with T. You cannot change this order because you've got to look at the etch marks. It went 1, 2, 3. So the etch marks have to go 1, 2, 3. That is super important geometry. Order always matters. When you're making a cake, order matters. So please be on the lookout for that. All right. So the last one, letter D. Imagine you are making a kite as an example 4. So this one is just like example 4, and it's page 159. So make sure you use that example to help there. And I did the other examples with you, and I think you guys are doing great. So I'm going to let you finish example D on your own, and you're also going to finish up the third one. I gave you the true statement, but you still have to go back and make all the angles and all the sides. But you can see that the corresponding parts of congruent triangles are congruent, and that's important truth you need to write down. Well, I'll catch you later this week for the next 2 lessons. So you've got 24, 25, and you'll also be doing 26 and 27. And I look forward to seeing you later this week, geometry. God bless you.